Hello and everybody to the April 2022 event for the Atlanta Kubernetes Meetup. We appreciate you all coming out and joining us. As always, we like to open up with a call for hiring in the community. If you or your organization are hiring anybody in the kind of Kubernetes cloud native space, go ahead and post the details in the chat. And after the news segment, I'll go ahead and read those out. Make sure you include kind of basic information about the role and who they should contact, and to get in touch if they're interested. I'll also post those in the show notes. So if you're watching the recording, you can check the link in the show notes below, and that'll include this information as well. And with that, while we get those typed up, I'll go ahead and hand over to my buddy Joe for the news.
Cool, thanks Alex. Welcome everyone. Get my screen shared here. All right, cool. Get a thumbs up from somebody on the panelists. All right, awesome, thanks. So this month in Kubernetes, this is still within the Kubernetes 1.24 release cycle. We have the first release candidate that's been dropped. There was a delay scheduled for this release due to a dependency on an update in Go 1.18.1, I believe it is. So the release team is basically queued and ready to go as soon as the fix is in that version of Golang. There were May 3rd is the new scheduled release date. Again, that is dependent on what happens with the Golang project and whatnot, but that's currently the set schedule. And we did have fixed releases this month for Kubernetes 1.23.6. 1.22.9, 1.21.12. These are general fix releases, so they've got some bug fixes, some regression fixes, things of that nature. I didn't see anything super crazy to call out, but just be mindful if you're on any of those versions. There are some new fix releases out there. Again, promotions and deprecations. This doesn't mean that nothing was promoted or deprecated, just nothing big to call out. As far as CVEs go, there were a couple of nasty CVEs for the Nginx ingress controller. I won't go into a lot of detail on these, but essentially there was the ability for an attacker to set specific patterns for the value of the path field in the HTTP rules in an ingress resource. So anyone that has write, update, access to ingress resources could potentially trigger this. That would allow access to service account tokens, which in a lot of cases with the Nginx ingress controller, the service account has permissions to read secrets across all, most if not all namespaces in a cluster. For things like certificates and different things like that. So this can be a pretty bad vulnerability here. Check out your clusters, check out the links here and read up on them. There is a new release of the Nginx ingress controller that has a mitigation for this. There's also a couple additional configurations where you can add essentially a list of field values to block in those fields with the native Nginx ingress controller admission controller. And you can also, there's some examples out in the wild now for how to do the same thing with Rego-based policy tools like OPA, Magtape, and Gatekeeper. So both of these are fairly similar, if I recall correctly, so I won't go into the second one there. But one of the PRs of note was pretty interesting. Time zone support, I've mixed up the wording here, but time zone support for Kubernetes cron jobs. Essentially, this is kind of what it says on the label. It gives an additional field for time zone in the cron job configuration that allows Kubernetes cron jobs to be scheduled not only on the time zone of the system that the cluster is running on, but across different time zones. So if you've got, follow the sun type clusters or anything like that, you've got large environments that are global, pretty handy there. Jumping into community news. So as I mentioned, there's Kubernetes version 1.24 is waiting on some fix for Go 1.18.1. That also means that all of the Kubernetes development tool chains are sort of moving over to use Go 1.18. So if you're doing any type of Kubernetes development upstream, make sure you're updating your development environment so you don't get caught by some of the checks and balances in the PR reviews and things of that nature. Client Go is being updated, and some of the other tool chains are being updated as well. So one interesting thing to call out is there was previously a bump of etcd to version 3.5, and there's been an issue open since then that there is a known kind of corruption or data inconsistency bug. So if you haven't upgraded to etcd 3.5, hold off for right now. If you have, check out the information related to this and see if there's anything that you can do to try to avoid or miss out on these things. But basically, you can have different members of the etcd cluster with different states of data, even though they all kind of have the shared state, the same shared state hash, and think they're all in the same version. So that can definitely lead to some bad things in Kubernetes land.
Yeah, I can speak firsthand and say that that's quite a bad one. I do believe that the release they did last week, 3.5.3, is now safe. It's now resolved.
Cool. So Kubernetes version 1.24 removals and deprecations. So this is a blog post out on the official Kubernetes project website. And it's a pretty good read through of just going through some of the stuff. I think we have all heard enough about Docker shim these days, but if you haven't heard for whatever reason, please read this article. But it also goes into some of the Kubernetes API removal and deprecations. There's a little bit of a change to that process now going forward with Kubernetes 1.24 to where beta APIs will be turned off by default. And this is part of the work to bring more stability to Kubernetes releases and the Kubernetes lifecycle. So that may be something kind of jarring if you have a hard dependency on a lot of beta version APIs. And then there are just different APIs that have been deprecated or changed. So this has a good list of those with some summaries about what those look like and links to the issues and PRs upstream of what's going on with that. So read through if you're looking at going to Kubernetes 1.24 when it drops. All right, so this is a really, really cool thing that I came across this month that I know myself and my colleagues have had different times throughout our careers working in Kubernetes where you need to do a packet capture because you're trying to figure out something that's going on within a container, a pod, a node, or across multiple nodes or multiple pods in a cluster, maybe across multiple clusters. And it's always kind of a pain to orchestrate all that stuff in the right way to where you've got stuff deployed in the right privileged mode and blah, 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 blah to get that. But then you still have multiple packet captures that you got to sort of wade through and correlate and all this stuff. Well, PacketStreamer is a project that is essentially a distributed packet capture mechanism. And it's really cool. A lot of times when you think about network packet captures, you think about the observer effect, and it can actually, consume a good amount of CPU and processing power to capture all that data and analyze it and do all that stuff. There's a really cool model here leaning on top of eBPF. eBPF, you can do some really lean stuff in efficient ways with talking to the kernel. So essentially all of its packet filtering and capture capabilities are instrumented through eBPF from what I read here, which is pretty cool. And that also means that basically anything that runs a Linux kernel, you can use this with, whether it's a virtual machine, a container, bare metal system, but it does look like it's also portable across things like, Fargate and Windows. So lots of really, really cool stuff with this. And essentially there's two parts. There's like the remote streamer that's going to capture on a given system and then send that data back to a receiver. And essentially one capture file gets generated, which is pretty cool. So there's a lot of stuff here around I'm not familiar with all the different acronyms and whatnot, but there's a lot of things that tie into some security analysis here, in addition to general like network packet analysis and things of that nature. But I'm pretty excited to try this one out and see more about it. One of the things that was announced in the community that's pretty cool, if you've used any of the managed Kubernetes services from the major cloud providers out there, typically they have a CNI that you get out of the box, and that's the one you get no matter what you want. Because it's pretty difficult to try to support an arbitrary CNI on something, you know, orchestrated like a managed service. So the work that the folks over at Microsoft and the Azure Kubernetes service space are doing is pretty cool, that essentially you can provision an AKS cluster without a CNI, and then you can bring your own CNI. So you have a lot more flexibility and a lot more options, which is pretty cool. Another interesting thing, a lot of folks are, you know, getting into the GitOps management of their Kubernetes platform and ecosystem, and Terraform has been a you know, crowd favorite in the community for a long time, and how you provision lots of different things in the cloud native space. GitLab as a platform introduced some new features that's pretty interesting, where essentially they have a managed Terraform state option. So rather than going out and provisioning like an S3 bucket somewhere to store and manage your Terraform state in a centralized way with locking and all that stuff, that's now built into the GitLab platform. And I think this goes for both the like GitLab open source and the GitLab SaaS offerings. It does have to be enabled in the tenant from like a admin perspective, but it's really cool to see a platform like GitLab continuing to integrate a lot of these sort of tertiary features that just simplify things a little bit more in the cloud native workflows these days. Another interesting thing, multi-tenancy has been kind of a big topic over the past couple years in the Kubernetes landscape. And I came across this project called Quebec. And essentially, it's a tool that allows you to manage Kubernetes resources across multiple environments. And it's based on JSONet, from what I understand, which is a blast from the past. I didn't think there's anything still rolling around with JSONet, but still has legs, apparently. But essentially, it gives you a lot of, it feels like a you know, customized JSONet type thing for generating some artifacts, but also orchestrating them across multiple clusters, even to the point of a higher level abstraction with like the generate name concept, to where you can have a pattern and it generates, you know, a unique name for the same deployment across multiple environments, which is pretty cool. So I think tools like this will kind of be coming into the limelight a lot more, as there's a lot of discussions around how do you manage tenancy, cluster, you know, cluster scope, namespace scope, different things of that nature. So, and then, you know, again, Capsule, it's a multi-tenancy operator for Kubernetes. And I think this one, that they applied for membership into the CNCF at the sandbox level, I think recently. But essentially, this has multi-tenancy from a policy-based perspective. And I won't go into all the things, but the concept is there's a like higher level boundary that's set that spans more than just a namespace. And it can almost in a delegation way allow users to manage Kubernetes resources at a little bit higher level than they normally would through standard Kubernetes RBAC, but still driven through policy enforcement and whatnot. So pretty interesting there. And with that, that wraps up this month in Kubernetes. Back over to you, Alex.
Very nice. If I happen to have a 1,000-yard stare on the recording of this, it's because of that etcd data corruption bug. That one was no joke. Seriously, you run kubectl commands and get different states back with no indication of why. It's a scary one. Yeah. All right, so looking at our hiring announcements, our buddy Max Snyder, longtime friend of the meetup here, is hiring for SREs on his team at Red Ventures. It looks like it's a remote-friendly role working on Red Ventures brand Healthgrade. There's a couple of links posted. Again, those will be in the show notes. Bubba just says sales. Okay. That was our only role posted. Moving on from that, as always, like to thank our sponsor, SalesSoft, for providing our webinar and all the fun licensing and things like that let us conduct this in an organized way, and in better times provide us with space and beer and pizza and all those fun things. We are hoping to get back in person sometime soon. Like we said last month, definitely let us know. Yeah, I think a lot of people are kind of ready to get back, but definitely curious to hear people's thoughts and feelings on that one. So moving on from there, again, as always, as our speakers are talking, you can use the Q&A feature built into Zoom. Abhi has said that he would prefer questions at the end, but go ahead and post them, and then he'll process those as they come in. Make sure to stick around until the end of the meetup if you like. We always have our social hour after our speakers are done. We'll everybody get on camera and on mic and chat, and we can talk about the horrors of etcd data corruption if you want. With that, I'm going to go ahead and hand it over to Mr. Abhi Selvan. He's the developer advocate at Red Kubes, and he's going to be talking to us about Kubernetes security and governance with Autome.
All right, thanks, Alex. And let me share my screen. You all can see it, right?
Yep.
Cool. So, hello everyone, this is Abhi, and I'm the developer advocate at Red Kubes. We are an early stage startup from the Netherlands. It's around 1:30 a.m. in the morning, but thanks for this opportunity where we could present our open source project, 100% open source project, Otomi. So in this talk, I'll be talking about the security policies and the network policies, and how you can easily apply these changes using our open source project. So let's get started. Just a little about myself. I've worked in industries, I'm Abhi, and I've worked in industries such as aerospace, autonomous robots, and finally landed in the DevOps world. Joined Red Kubes last year as the developer advocate. Exploring and learning in this cloud native space. Outside of work, I love endurance running and cycling. Netherlands also has very good cycle paths, so we can cycle a lot here. And feel free to let's connect. And I'm Diabe on Twitter, and Abhimanyu Selvan, my full name, on LinkedIn. So it'll be really nice to connect with you all. So let's go. Today's agenda, a quick intro about our platform, and we'll go hands-on with a demo. And it's in two parts. First, we go over the container security policies, and then another demo on network policies. And the most important part is, as an open source company, we're looking for contributors and community members to try out our product and provide feedback or suggestions. So yeah, how can you contribute? So just a quick slide on that. Oops. Skipped. Yeah. Autome. It's a self-hosted platform as a service for Kubernetes. It is a 100% open source project, cloud agnostic. We also recently got it working on DigitalOcean Linode as well. And you can also install it on Minikube. It's an entire layer on top of Kubernetes, where through one single web console, you have all the open source applications integrated. And these apps are also tenant aware. So we have a concept of teams in Autome. Teams is not just a namespace, but also coupled with RBAC policies. And so per team, you can also have these apps completely integrated. You don't have to do any wiring yourself. Don't need to write YAML. We will show you shortly. Through drag and drop, you can activate these apps and get started with it. But in today's demo, we'll mainly focus on the network policies. And yeah, and you can easily install it with the Helm chart. So feel free to try it out. I will also provide the links to our GitHub project, so you can try it out. So let's get started with our demo now. So what I'll be basically doing is I'm first going to deploy a rogue pod. I'm sure most of you are very, very familiar with these, but we're going to deploy this, and then I'm going to jump into the console. I'm going to enable these policies without writing any YAML, and then we'll try to deploy it, and you'll see that under the hood, OPA Gatekeeper comes into play and prevents the creation of this pod. So yeah, let's jump. I'll skip, and sure you can see my terminal, but I will. All right, so this is our Automi console. The moment you install, you'll be able, we will generate a username and a password, but you can also give your own credentials, just log in into the platform. And this is an admin view. So as an admin, I have access to a lot of other things, but also I can create like a team user who has limited access. And as an admin, you can also control what the team user can see or what apps can the team user use. But now we are logged in as a user, as an admin user. And on the left side of the console, you can see that there is some policies. All right, I just got logged out. Let me log in again. So these passwords I'll destroy the cluster anyway. And these passwords are generated, so it doesn't matter. So these policies, you see, by default, we enable all these policies, but for the sake of demo, I've disabled them so that I can play with it. Right, first let's go and deploy the pod. So first let's see, yes. So this is the manifest, and I'm going to deploy this pod now in the Team Atlanta namespace so I've created a team just for this, to speed up the demo, created a team already called Team Atlanta, and I'm going to deploy this pod there. Let's go. So slow. My PC is crying. All right. So I was able to create this pod. So as you know that I have now, I can access the host file systems, and this is quite dangerous, you all know. So let's delete it right away. My PC is acting up. Whoa. Am I connected? Yes.
Zoom needs a lot more resources than people expect. Doing a demo along with Zoom running is always tough.
Oh. All right. As it's getting deleted, so let's go into the policies now, and let me enable the host file system. You can also make it read-only, and you can only specify the parts that you want to read, and so you'll just enable it and submit. Let's also enable the other policies because we have the host PID flag, so let's also enable it. And what else? There's privileged container, enable it. All right. Are these the ones? Let's see. Host file system, host security, privileged containers, cool. Deploy changes. So what happens is Automi comes built in with Gitty as a repository and also drone activated. So any changes that you make in the console automatically gets translated into the YAML. And these changes are, so the commit is made to the Git repository, and then we have a drone pipeline that is activated. And once the pipeline is exceeded, the result gets applied to the Kubernetes cluster. So I'll show you what's happening under the hood now. So if you go into the apps, so you have Gitty now. Let's go into Gitty. So when you install Otomi, so all the configurations are now in this repository, which is automatically created, and any changes that you make gets committed. So the change that we made now is we've set all these flags, so it automatically generates this YAML, which under the hood we use a lot of Helm file templating to match. And now a drone pipeline is activated. So check the drone pipeline. So first checks out, and it also performs a lot of tests to validate the schema and then check all the policies. And once the test passes, the changes gets applied. So this way, an admin, a DevOps admin, can easily monitor what changes is going on. And we also have a CLI, so you can also directly interact with this Git repository to our CLI. So it's taking some time. Yes, so now these changes have been applied. And so let's go back. Yes. And if I now try to deploy the pod, let's see what happens. You see, so the policies, the OPA Gatekeeper admission control is now denied because we've enabled the policies, and like you said, like you've just seen it, not using YAML or anything. So yeah, this is a quick demo in terms of the pod security policies. So now I will switch to network policies. For the network policies, what we're going to do is we're going to use a 3-tier microservice application. It's a guestbook application. It's available as Google platform. I think it's one of their demo apps. So there's a front end and there's a Redis leader and a follower. So what we're going to do now, by default, we're going to allow the traffic to flow through. So we're going to apply this manifest, and we'll expose the front end service through the Automi console, and we'll be able to access the application. And then we're going to apply the network policies. And then you'll see that the traffic is denied, and then we're going to whitelist all the endpoints, and then you'll see that the application will come back online. I'm not going to write anything. Everything is going to happen through the console. We can also on one side terminal watch what's happening, like what network policies are created. So let's jump in. Let me apply the guestbook manifest. So I'm gonna now apply the guestbook YAML, the Atlanta namespace. Yes, so if I go to K9S, you can see, yeah, services. Now I will move to Automi console. So here, as an admin, I can choose which team or which tenant I want to be a part of. Now I'm at the Atlanta namespace, so I'm going here. I'm going to services to expose the front-end application that we just deployed. So I'm gonna create a service, and the name should match the name of the pod. It's an existing Kubernetes service. I'll make it public. So under the hood, we use Istio and along with Ingress. Automi automatically configures the virtual services and the Ingress gateway to expose the front-end app here. So let's click deploy. Same through the GitOps pattern. Any change that you're making generates configuration, and then that gets deployed and applied. So it might take a while. Let's look at drone, what's happening. You see now the pipeline is triggered. Let's see what the commit is. Right. In the team config, under the team, so these are the services, and this configuration is what we filled in the form and in the console. But this gets translated internally through a lot of templating mechanism that's implemented. So let's go here. The tests are running. Tests are done. while it's happening, I can also show you this part of things. So any app that you want to integrate is just a drag and drop. So if you want to use Grafana or Harbor to manage your registry, or you can also use Harbor. So you drag and drop Harbor, that gets automatically activated. Let's see if the pipeline is done. Not yet. Yes, so now it's done. And let's go back to services. Yes, so the apps has been exposed. So welcome to, okay, it is Atlanta Meetup, right? Yep. The demo gods are with us, so far so good. And so now what I'm going to do is I'm going to enable the ingress filtering. So let's go to the team. Where's the team? For teams, well, you can specify the resource quota, you can specify the filtering here. So under the hood, what's happening is we're using network policies and Istio service mesh to enable the ingress and egress filtering. So I'm gonna enable it and submit, deploy changes. So when this takes effect, so basically, wow, it's so slow. All right, so there won't be any traffic, so all the inter-service communications will be cut off, so we won't be able to like communicate with the leader or the follower anymore from the front end. So let's go back. See, the flag is now set to true and the pipeline is triggered. We can also watch the network policies on one side. So we'll see some watching the network policies here. So if this goes fine, you will see that there should be a deny policy generated. Yeah, so you can see at least in the logs now, we can see that the network policy was generated automatically with all the configurations needed. And yeah, so the ingress deny policy was applied. So let's go back to our application and see what's happening. Front end, well, the message is gone. So if I say hello, yeah, nothing is happening. So the communication between the services is broken. So let's start whitelisting them. So in order to whitelist them, we need to register these services into the Automi console so that through the console, I can whitelist the services. And it can also happen between teams, right? I mean, if let's say there's a entire front-end team that's working on this front-end application, there's another database team. So you can also whitelist between tenants. Let's create a service. So what I'm going to do is create or register the Redis leader service. It's an existing service. I don't want to make it public. So I'm going to say in ingress traffic, I'm going to say allow selected. I'm going to specify the team name. In our case, it's the Atlanta team. Oops. And the service name, I want the front end to talk to the leader. And let's add another one. I want the Redis follower to also talk with the leader. And I'm going to click submit. And I'll create the follower service. Redis follower. God, it's so slow. Let's go. Same port, existing service, allow selected. And since this is a follower, I'm going to say on the Atlanta namespace, let the front end talk to the follower. Submit. Just to verify the leader, this port, existing service, allow Atlanta front end, Atlanta Redis follower. Good. So let's deploy these changes. There's a new commit. The entire policy is automatically configured here. Pipeline triggered. Let's go into the pipeline. I'll close all these tabs that's not used anymore. We just do static validation here. We don't do anything more than that. We do some schema validation and the policy checks in the tests. We use Istio as our service mesh under the hood, and at this moment, it's not possible to replace Istio with another service mesh like Kuma mesh or something else. Yeah. But every other app is configurable. Earlier, we had like a very opinionated stack, but then we made it really configurable, and also that also reduces the footprint to install. That's why you can install this entire platform on Minikube now, right? So you can see that two new policies.
Abhi, on that note, Scott actually asked in the chat, does it support pluggable Git backends, or does it have to be Git-T?
No, so I mean, for Autome configurations, the configurations that you do via the console is automatically in Git-T. But you can also, I mean, for your for your projects, you can sync up GitHub projects, and then you can like mirror them either in Harbor. But in the new release, we are also introducing Argo CD. So that was the missing part of the puzzle. So with the new release, we'll now just have Argo CD as an app integrated, and then any commit that you make in GitHub or in your own registry can easily be applied. But the configurations that's happening within the console goes to Git. But I need to, we did get this question, like, can we use another repository to store Autome values in their own registry? At this moment, it's not possible, but we're also working on to make that also an optional feature. So you can see that two new policies were created, and hopefully, not hopefully, it should work. Let's see. I also don't want to be overconfident. Yes, so it's back. So now what we did was we were able to whitelist the applications, and so we're enforcing zero trust networking here. Yeah, and then we have ultimate control over who's talking to what endpoints can be exposed and within the services. So we are back. Yeah, that's in short, like the demo that I wanted to show. I can also, so yeah, a little bit about, I'll just wrap it up and then we can have some questions. You can find us at redkube/Autome core. It's our open source project. You can just check it out and also support us. So we're really looking for people to try it out. And if you have questions, reach out to us. We are quite responsive, and we want more feedback on our product and or suggestions. Hey, maybe you guys can use this, or have you tried this? Or we're looking for some feedbacks. And you like I said, we are not wrapping anything over. We are presenting all the apps as is, and we are an open source first company. We don't even ask you to log in and do anything. So we don't write any wrapper or around layer around Grafana or anything. We present the Grafana for all the apps as is. And you can join redkubes.com/community. We have a Slack channel, and recently we also opened a YouTube channel where we're creating some small demos. Last week we presented at Microsoft, and we also have our labs now with the Azure Hackfest repository. So you can also try out the labs. So basically, after install, what all can you do? Like create teams, applying policies, enabling apps, using Knative apps, things like that. But the plan is I want to extend these labs so that there are so many apps going on or applications there. So we want to also get some use cases and see how we can enable it. So that's the demo, and thankfully the demo went fine. And I can also switch back to the console and then just show you some other things around if you're interested, or some questions, you can answer them. So thank you very much for this opportunity to present our product. And yeah, thank you very much.
Absolutely. Thank you so much for coming and talking with us, Abhi. There were some other questions through the event. I think people are using the chat interface instead of the Q&A, so you might have missed them. Overlord asks, can I run this on Raspberry Pi? So I'm guessing really does it support ARM? Does it support running on ARM architecture? No, it doesn't support ARM right now. Okay.
Yeah, and we are looking into it. Got it working last week in like Minikube for Windows and Minikube for Mac. That's the least we could come to, like the minimum. Raspberry Pi is next in our thing. Yeah.
Cool.
And all K3s, we also want to try it on K3s. We did try it on Civo Cloud, but there were like some issues with ingress, load balancer issues. So still need to figure that part out. But yeah, you can try it on Minikube for Mac or Windows if you don't want to spin up a cluster, but it also runs on AWS, Azure, GCP, Linode, and DigitalOcean as of today.
Very cool. Awesome. Well, thanks so much for staying up late and coming and talking with us, Abhi. We appreciate it.
Thank you very much for the opportunity. Thank you very much.
Absolutely. All right, up next, we've got a good friend of the meetup, somebody who's come and graced us with his presence many times now. We're looking forward to hearing another talk from him, Mr. Duffie Cooley, the field CTO at Isovalent, the makers of Cilium. And he's going to be talking to us about using Cilium and Multus.
Exactly. Good to see you all. So in this situation, I'm going to try to have the chat window open over here so I can also see questions that are popping up. But you know, feel free to, if you see a question that I don't see, feel free to just throw it out there and like interrupt me as we go. Thank you so much, Abhi. That was great presentation. It looks like a very awesome product. Lots of good stuff in there. Let me share my screen here. All right. Okay, so I put a link to this document in the meetup notes. So if you want to follow along with me, this is actually where you'll find a lot of the information. The point of this presentation is actually a walk through an interesting project called Multus and like what you can do with it. And then also we're going to use Multus to basically we're going to take an existing cluster with Flannel running. We're going to install Multus on top of it. And then we're going to use Multus, and then we're going to install Cilium on top of it. And then we're going to kind of like switch some of the configuration of applications from the final into the installed CNI, which was Flannel, and to using Cilium. And then we're going to show that we can still connect back and forth between applications in either CNI leveraging Multus. without actually doing like a crazy like cluster teardown and recreation and that kind of stuff. But it is pretty neat stuff. So I want to kind of get into it and explore this stuff. First thing I wanted to say was, if you are going to Valencia, whether virtually or in real life, definitely make sure that you check out the pre-show, the co-hosted event that we're doing, which is EBPF Day. A good reminder for those attending virtually that this year at KubeCon EU, all co-hosted events are included in your ticket price. So when you pay that virtual ticket price, the co-hosted events are a part of it. So, you know, don't miss out on that stuff. That stuff is happening the day before the event, and there's a ton of really incredible co-hosted events, not just the EBPF Day. If you are going in person, however, you do need to register to be in the room. But I hope to see you there if you are being in person, and if you are virtually, then I'll probably interact with you on Slack, and it'll be good to see you then too. Multus CNI, what is it? It is pretty darn cool. This is the GitHub project that is associated with it. It's been moved under the K8 Network Plumbing Working Group. Before, it was actually part of the Intel incubating project. And so it was hosted somewhere else before. I can't remember what it was, like Intel container startup thing or something like that. And that repository still exists, but this is actually where the work is being done. So if you're looking for like, where is Multus? This is where it is. This is like where you would see the recent commits and any changes that are happening. And they have some pretty good documentation, kind of taking you through kind of the quick start installation. But Multus is, you can think of it as a meta CNI. By default, inside of most Kubernetes clusters that are out there today, you're leveraging already kind of another technology that's called CNI. And the CNI basically turns the networking stack that Kubernetes will use to wire up all of those pods as part of a network into kind of a pluggable format. For the most part, people only just have like the one plug, right? They're going to install Calico, they're going to install Cilium, they're going to install Flannel. To Joe and Alex's point, like if you're inside of a managed Kubernetes cluster, you probably don't even make that choice yourself, but regardless, you're still going to kind of make use of a third-party CNI of some kind as part of that managed cluster. They're just going to pick it for you. Could be the AWS CNI, could be the AKS CNI, could be ANetD, which is actually still Cilium under the covers. Pretty cool stuff inside of Google, instead of GKE. The neat thing about Multus is it enables you to effectively have multiple things configured. So you could actually deploy Multus, and then you would have whatever the CNI was that you started with, and then deploy a different one, and then, you know, maybe even support a migration use case. Like I want to move from whatever I have to something else, but before I do that, before I like throw everything over to the new CNI, how can I actually build confidence? How can I be sure that this is actually going to work, right? And Multus is actually a pretty interesting way to do that. Now, when I was reading through the Quick Start installation guide, I was a little surprised by this, because I was used to the idea that, like, if you're going to make a change to something so low level as a CNI, then you kind of have to start with that change, right? Like I was expecting it to say, like, you got to wipe out the cluster, and then you would install Multus, and then you would install whatever the default CNI is, and then you would be able to like get pretty creative about how things work. But that's actually not how Multus works. So we're going to play with how Multus works and what that actually means. But before we do that, a couple other things I wanted to show you. This migration use case, which I link, is actually something I'm planning on revamping. But this is a migration use case that was put together by JetStack, and we worked closely with them. But this was an effort to do exactly this, you know, like basically take whatever the existing CNI was and move it to a different CNI. Some of the reasons why you might want to do such a thing, if you think about it, like a lot of times when we talk about Kubernetes and the applications that we deploy on top of it, we talk about those things being stateless, right? So if you had stateless applications like an Nginx server or, you know, that kind of stuff, it would probably be okay for you to just rebuild your cluster and you know, with a new CNI. But what if you had state? What if you had databases and persistent volumes and all kinds of stuff like that? And, you know, rebuilding your cluster from scratch is actually comes at a higher cost. You know, it basically makes you think about that problem a little bit differently. So the So that's why in some cases it actually may make sense for you to migrate CNIs underneath your existing cluster. This story here, this migrations case actually gets into it. And there was actually some pretty interesting Go application written in here to basically kind of like automate this. And so if you're interested in that kind of work, it's definitely worth kind of checking out. I thought it was pretty impressive. So you may have heard of Multus, but where have you heard of Multus? Like, where are people leveraging Multus today? Pretty much all of the platforms that I'm aware of out there, like either already support it or are working towards supporting it. So for example, in OpenShift, if you're going to leverage a third-party CNI and not one of the built-in CNIs that are part of your OpenShift cluster, they take you through this model where you're deploying the CNI in kind of a custom way, and that leverages Multus under the covers. And so OpenShift actually carries a fork of Multus that they use for OpenShift. Rancher RKE2 supports a pretty interesting method where when you're picking the CNI for your Rancher Kubernetes engine-based cluster, you can actually pass the CNI flag multiple times, or you can do comma delineated. In this case, it would actually install Multus and whatever your CNI is, which is pretty neat. KubeSpace supports it. AWS EKS. If you're playing with EKS, it now actually supports the CNI. So if you wanted to have if you wanted to enable overlay networking as part of your EKS deployment and have the majority of your workloads out there on that overlay network, but then have some of your workloads be part of the routable pod network that is provided by the AWS CNI, then that is a use case that could be supported by Multus inside of EKS. And if you want to read more about that, definitely check it out. It's pretty cool. Tanzu, which is one of the other Kubernetes distributions for bare metal out there, supports it. Anthos supports it. When we talk about what Multus is doing in the definition of a network attachment, it actually opens up a variety of other interesting use cases. Like, for example, as we go back to the Multus documentation, one of the other examples that they highlight is this idea of actually having multiple interfaces in the pod. Now that you have the ability to understand multiple connection types, maybe you want an SRIOV interface and an overlay interface, and you want to be able to configure those things so that they can live together in the same pod. These particular pods, maybe they'll be receiving multicast traffic on the SRIOV interface, but they're going to be like actually interacting with like a database on the overlay network so that they can process data from multicast and kick it off into some different part of the architecture that you've developed. So Multus, in my opinion, is an incredible tool and probably deserves to be a part of your stack. Even if you're just using it to kind of like understand how to handle those advanced networking use cases that you might have, Multus really provides you a lot of really incredible tools for that. Any questions that you have, please let me know and we'll dig into it. So this is what we're going to be digging into here. This is basically our goal for the day. We're going to bring up a cluster leveraging Flannel. I've already done that bit. I'm going to show you how that works. And then we're going to show how the pod is configured with the IP address that's associated with it. And then on that existing cluster, we're going to deploy Multus on top. And we're going to do the Cilium piece, and then we're going to kind of take multiple steps here to kind of show you how all of this works. So let's get started with the fun stuff here.
Hey, Duffie, quick question. Does Multus basically have the assumption that like you need to start out with another CNI for like the actual like network plumbing bits and whatnot? Or does Multus itself handle some of that on its own?
So you have choices actually in that scenario. Give me 1 second. I'm actually trying to get my desktop to share while so let me single task that. There we go. Okay. So you have choices. You can already have an existing CNI deployed and then deploy Multus on top of it. You could deploy Multus and that CNI together. Or you could deploy, it's like you can kind of do it any which way that you want. Right, whether Multus was a part of the original stack or not can be determined at any point. Does that answer your question?
Slightly, just like, do you have to have something else, like another CNI chained in
Can
with-
Multus do the work? Is that what you're asking? No,
yeah.
it cannot. Multus is
Okay.
a meta CNI. It doesn't have any built-in functionality of its own.
Cool.
Yeah, basically think of it like this. When the kubelet makes a call to create a pod, and it's going to call out to the CNI and have the CNI do all of the heavy lifting, like maybe wire up a couple of VETH pair, put one part of the VETH pair inside of that network namespace that's going to be associated with your Kubernetes pod and all of that. Multus sits in between the kubelet and whatever CNI or network attachment definition that you define, and determines, based on the annotation you've associated with that pod, which CNI to pass this request to, or which CNIs. Like, you could actually pass this request to multiple CNIs and get back multiple interfaces associated with that pod. But it's really just doing the director part of it, right? It's basically saying, you've configured this based on annotations that I understand from the KH networking group, that you want this to be a part of the default CNI. So I will pass this request to Flannel in this case, right? But if maybe I want it to be a part of Flannel and I want it to be part of Cilium, then I'd basically configure the pod in annotations saying that I want it to be part of both. And I would be able to see that both interfaces are provided to that pod. But Multus itself doesn't do any of that bit. I mean, it doesn't do any like wiring up of VETHs or any of that noise. Good question. So what I've got is a kind cluster. I think I've said that probably about 1 million times in my lifetime at this point. And the kind cluster is 4 nodes. I have a control plane node and 3 worker nodes. And the way that I configured it when I brought it up was using this method here, where basically I brought up the kind cluster without a CNI, and that's because I wanted to configure this with Flannel. So if I look at the pods that are running in the kube system namespace, we can see that the only thing running in the kube system namespace is a pretty standard Kubernetes control plane. We've got our core DNS pods, etcd, we've got the static control planes that make up a kubeadm based cluster. And then we have the kube Flannel daemon set operating, and kube proxy and the kube scheduler. And if I do a kubectl get pods, I can see that I've created a deployment, and it's called echo. And if I do that same command, YAML, and I scroll up here to the top, I can actually see some of the information about this pod itself, including the IP address associated with this pod, right? Here's the pod's IP address, and that is basically just using Flannel. So the way Flannel works is it's going to look at the nodes, the nodes IP set configuration, and it will basically allocate IP addresses to pods based on that. And so it's a very, very simple way of actually wiring up pods inside of your, from a networking perspective. Flannel doesn't have any network security or anything else like that. It's built into it. It's just a way of actually providing connectivity. Super simple one. So our next step here is that we're going to deploy Multus on top of it. And to do that, I'm going to grab this Multus daemon set and apply that. And before I do that, I'm going to find curl minus LO. I want to take a look at this daemon set before we apply it. So you've heard me talk about network attachment definitions, and this daemon set is going to install Multus as a product inside of the cluster. So the first thing it's going to do is it's going to define that CRD so that when we further define network attachment definitions, it actually has the definition of that custom resource will be present inside of the cluster. Then we're going to go down into some RBAC stuff. So it's going to create a cluster role that it's going to associate with the Multus service account. And this cluster role is going to have the ability to update, delete, and patch any pods. Actually, for pods, it's going to do a get and an update. So it's going to be able to actually update the configuration of pods, and it's also going to be able to get all pods. And it's going to be able to do that for pods and pod statuses. It's going to have the ability to send events to the Kubernetes event stream. It doesn't have any delete functionality. It's also going to have complete control over the K8's CNI CNCF.io API group. And then here's the role binding. So it's going to associate that role binding with Multus in the kube system namespace. That's the creation of the service account. And then there's a config map that is actually going to lay down the CNI configuration for Multus inside of this environment. Further down, we have a daemon set, where the daemon set is actually going to deploy Multus as a running application on all nodes. And it's going to make use of a couple of different flags, including this Multus conf file auto, which is the flag that means that when you see this config map inside of the kube system namespace, I want you to lay that down on the file system. This configuration further goes on to describe a host path mount of the underlying host for all of the relevant directories like ops CNI bin and etc CNI netd, which is where like Multus actually starts taking control of what's happening inside of those directories and how to apply those things. It's got resources and memory associated with it, not very much of it at all. And then that's the entire configuration. So one thing I wanted to change here real quick, which I forgot to do earlier, is that. All right, so there we go. So I'm going to go ahead and apply this. And then if we do kubectl get pod session kube system, we're going to see those things deploying. Now, usually if you deploy another CNI into your cluster, you can expect things to get a little weird because like at that point, you may have actually changed the underlying routing configuration. You may have changed a number of different things about the system. But in our case, all we've really done is add that director piece in front of the flannel configuration. So if I do kubectl get pod session kube system one more time, you see it's almost there. I'm going to jump into one of the nodes here. And I am going to take a look at the underlying file system. We're going to take you on a whirlwind tour real quick of like what a CNI is going to do for us here. So cluster control plane bash. So this is kind of like if you SSH into your Kubernetes node, we're going to jump into the control plane node and look around. So there's a couple of key directories with relation to a CNI. The first one is opt CNI bin. Opt CNI bin usually has all of the binaries that are going to be used when the kubelet makes a call to the wired CNI. In our case, we have added a Multus binary, and we already had the flannel binary already wired up in here. And then there's like how we configure the kubelet to actually talk to all of this stuff. So CNI netd handles that. And that directory looks like this. I have two configuration files right now. And then I have this Multus D directory. So by default, I mean, in most normal cases, even if we were looking at this before Multus had been deployed, we would not see this 00 Multus config, and we would not see this directory. The way the kubelet determines which CNI to pass the request to is by basically lexically ordering all of the configurations in this directory and taking the first match. So in this case, we've injected one, right? We put Multus before flannel. And that means that any subsequent request to make a new pod is going to go through Multus. And we can prove that here in just a second in this part of this demonstration. So let's take a look at that Multus configuration before we do the proof of it here. This Multus configuration does kind of exactly what we were talking about before. What it's going to do is it's going to basically wire itself up as a CNI, and then it's going to delegate all of the heavy lifting for wiring up pods to Flannel. So any wiring up of pods that needs to happen will go to Flannel. It's not going to do any of that work itself. This is basically how Multus will work. So Multus will basically just delegate any of that connection stuff to Flannel, and it won't do any of that heavy lifting itself. If I do an IP link, I can see the Flannel 1 interface, and all of that stuff is working. So let's go ahead and show that now Multus is in the way. Before I showed you, I had this pod running inside of the default namespace, which was the Echo pod. And if I were to do kubectl get pod echo names -o YAML, let's just, again, I have I can see the IP address associated with it, but there's not really like a bunch of annotations or anything interesting about this. This is just the way that Flannel does it. If I did kubectl rollout restart deployment echo, I should see the new one come up pretty quick. There it is. And if I were to do that same command of kubectl get pods -o YAML, I can see it still has an IP address. It's good. But up here at the top, I have a whole bunch of other information. This is an artifact of having Multus running under the scenes, right? And so this happens because now Multus is in the path and it's annotating the pod with what decision it made and the information that it basically got back from the CNI when it made that request. And so Multus said, hey, default CNI, give me an IP address and give me some other information back. And this information basically came back from Plano saying, okay, here's the information that you need. Off you go, wire that up to the pod, and away we go. So now we've just installed Multus into a working cluster. We didn't break the cluster, but now as part of a side benefit, we're getting more information back from like what's actually happening at that CNI layer. Pretty cool stuff. So now kind of another interesting piece. So I'm going to actually deploy Cilium in here. Now Cilium by default also uses VXLAN, and it does a couple other things. So Cilium by default will also basically take exclusive control of the CNI directories because it thinks that it's going to be your only CNI. Now, fortunately, all of those things are configurable. Okay. So this is what that configuration might look like, right? So I'm going to do a Cilium install. I'm going to tell it to use cluster pool as the IPAM piece of it. And that's because I don't want any overlapping IP addresses between the final deployment and the configuration that I'm creating. And so in my case, I'm going to tell Cilium to install using cluster pool, so use its own IPAM. And I'm going to tell it that the CIDR that I want it to actually allocate is 1100/16, so it doesn't overlap with this 10244 business. I'm going to tell it to use a different tunnel type. So instead of using VXLAN as an encapsulation, I'm going to use Geneve for an encapsulation. And that way I don't conflict with that VXLAN piece of it either. And then I'm turning off that exclusive ownership of the CNI directory. And I'm not actually going to deploy the CNI configuration into the CNI directory because there's no reason for me to put it in there at the moment. There's already all of that stuff configured by Multus and by Flannel. And I'm actually going to use a different mechanism to wire up the definition of what Cilium means. Let's go ahead and deploy this. Now, we've recently made some changes to the Cilium CLI, which I'm actually pretty excited about. Previously, we had been doing a lot of Go templating for all of the manifests in the product itself, right, in the Cilium CLI itself. And we've recently moved to, instead of actually doing all of that work, we actually give you the exact command that we use to generate all of the manifests that we're going to apply to the cluster. So this is a Helm template command, leveraging the Cilium the Cilium Helm chart to actually wire all of that stuff up. And all of the values that we pass to it. So now if I do kubectl get pods -n kube system, I can see that I have, Cilium deployed. And if I do Cilium status, Cilium is deployed and operating, and final is still there. And nothing has really changed from the pods perspective, right? So if I do kubectl get pods, I can still see that the application is working, and I can still interact with that application. Kubectl get. So here's like a kind of a interesting hack. What this command does is it will do a get raw against the API, the Kubernetes API, and I'm actually going to send that request. I'm going to proxy this request to the echo service running in the default namespace, and I'm just going to see what response I get back, right? So this is that echo pod running inside of the cluster. It's running at 10.244 2.4, and it's a part of the final network. So I'm still able to interact with it. Everything is continuing to work. So why put Cilium in here if I'm not going to use it? So the next piece here is actually to deploy something such that I can actually kind of maybe like rewire this particular application to use Cilium instead of using Flannel for its network. So let's play with that. So I'm going to go ahead and apply this. Let's take a look at this configuration first. So this is a network attachment definition for Multus. And what this network attachment definition looks like is very similar to what you might see sitting inside of that etc CNI netd directory, because this is just the configuration that tells the kubelet, or basically informs the kubelet where the binary is, what to call this particular CNI configuration, and then any flags that you want to actually pass to the CNI that it takes, you can actually also include this, right? So this enable debug is actually about telling Cilium whether or not to send debug logs to its in the output. If I apply this configuration, Cilium network attachment, to the kube system namespace, kubectl apply -f, then I've defined for the kube system namespace a different connection profile that I can then make use of for pods inside of that kube system namespace. Now, by default, again, it's not going to do that. It's not going to make any changes. So like everything in the kube system namespace is still going to be part of the Flannel network, but I want to go ahead and move core DNS into the Cilium network. One of the ways to determine in Cilium if you actually have anything wired up is this command. Cilium endpoints, for any running pod that we know about that is part of the Cilium fabric, we would actually see a Cilium endpoint associated with it. That's actually how we know that it's a part of the Cilium fabric. So if you do kubectl get Cilium endpoints and you don't see anything back, then you're not really running Cilium. There was something else going on, right? So now that we've actually established that, let's go ahead and move the core DNS pods to Cilium and see what that looks like. So I'm going to do a kubectl edit deployment -n kube system core DNS. And then inside of the configuration for the core DNS pod, for the annotations side of it, gotta look this one up real quick. So where did I put that? Hold on a second. In the configuration docs, they describe a way to annotate pods such that you change the default network, and that is this annotation here. This is basically configuring the Multus CNI. It's telling it the default network, and then I just give it the name of the network that I've created. So in my configuration, I created a network attachment called Cilium Conf. Get network attachments -A. So that was called Cilium Conf, and it was wired into the kube system namespace. And that means that any deployment that I have in that kube system namespace, I can rewire to use the Cilium Conf configuration. So let's say kubectl get pods -o y-n kube system. And now we can see that something has changed. So the core DNS pods have actually just been restarted. They've been up for 23 seconds now because it was a pretty quick restart. But they have an 11.0.0 address instead of a 10.244 address. And if I do a kubectl get pod -n kube system core DNS, and just pick one of them, b-o YAML, and we go up here to the top like we did before, then we can see that this configuration, it's using the kube system Cilium Conf. This is the interface inside the pod. This is the IP address allocated to it. Its MAC address. It's part of the default. It's going to use the default route. And that is the configuration that it got back from the Cilium's CNI. And if I also look at the kubectl get CEP-n kube system, you can see that these have identities and endpoint IDs, and they're part of the Cilium fabric. Now, one of the other questions you might have is, does DNS still work? Because it's always DNS, am I right? It's always DNS. So now that we've actually just moved DNS as a function into a completely different network, did we just break the world? Anybody, any bets, any guesses? I'm curious. Who's with me so far?
Let's see the world burn.
I trust you, Duffie.
You trust me. I appreciate that. You know,
I trust Duffie. I don't trust DNS.
that's kind of how I feel. I trust Duffie, and I don't trust DNS either. I think that's a reasonable place to be. Oh. Kubectl get pods. Kubectl exec ti. Oh, that's right. I don't have anything in there. Okay, so let's do kubectl run it. Image equals bash. Boop. Little one-liner for creating a little pod real quick. And if I do IPA, I'm part of the Flannel network. And if I do APK update, what? APK add curl google.com. Oh yeah. DNS continues to work. Let's see, resolve.conf. It's still resolving to 10.96.0.10. And that is the only DNS servers I have in the cluster right now are those ones that are running in 11.11. So if I go back and just to prove that this is working between the two endpoints, I'm actually going to grab that IP and I'm going to ping it. And I'll ping the other one because it's on a different node, just to prove that it's not like some wacky thing where it's working because it's on the same node. So in this scenario, this gives us the ability to determine which pods we want to be a part of which fabric. Now, there's trade-offs here, right? Like anything that's in the Flannel network is effectively invisible to Cilium. Like Cilium can't although you could define network policy that would include the IP addresses of things running within a given namespace, it wouldn't really understand how to map those things in the context of Cilium because we don't know about those endpoints. And so this is just a way of handling a model where you're going to do like a migration where you have things in the Flannel network, but now you actually want to start moving everything into the Cilium network so that then you can start making use of things like network policy and a lot of the other bits that are available to you within Cilium's view of the world. That was the live demo. We actually made it through. The demo gods were on our side, and I was able to show you all of the things. Let me go back to my notes real quick and make sure that I have covered everything I wanted to cover. Let's see here.
So this sounds like a terrible idea, but
Oh, it's totally a terrible idea.
no. My idea. Could
Oh.
you run Multus outside of Kubernetes? Like, can you run Multus on a node itself without having it be a daemon set? Or so
yeah, I mean, it's totally a thing.
it's a thing. Okay.
Yeah, I mean, like, so if you think about it, all the daemon set is doing is it's trying to apply some consistent configuration across the set of nodes that match that node selector related to that daemon set, right? So you could absolutely say, look, you know what? I want to configure, some node pool in this way, and all of the other nodes will not include this Multus business, right? So like and if I edited the Multus daemon set and I had a node selector that was like, wild guess node set, right? Then all of the stuff I just did would only apply to the wild guess node set. It wouldn't apply to the rest of the cluster.
Oh, well, the thing that I was actually suggesting is, like, could you run Multus as a systemd service, for example, instead of let's say you want to do something tricky and you want Multus to come up early, could you run it as I guess you could always just run it as like a static pod on the machine as well. But does that make any sense? Like,
technically you could, yeah.
It's just a bad idea.
I mean, generally speaking, I would say that like the trade-off between like doing something like this in systemd and doing something like this in a daemon set, in my opinion, almost always, I will almost always push you toward the daemon set model, because one of the things that you get out of that is the ability to dynamically change the configuration of those bits. Wherein like with systemd, you have to handle the whole orchestration of configuring all of those bits, right? So they're but then I'm all in on this cloud native stuff, right? Like I think that like, making use of an orchestrator like Kubernetes to handle all of those pieces pays huge dividends. Like even over like the idea of static pods, like I would, if you can move it into the place where you're actually able to, dynamically configure it and handle upgrades and handle all of those pieces and get all of that value out of the orchestrator, then I need a really good reason why you're not. You know what I mean? Like,
oh yeah, for sure. I just didn't know if there was something in Multus,
no,
or if it was like, huh?
It's just a process, just like everything else.
Everything is a process, right?
Yeah,
yeah. So, yeah.
It's just another file, Questions, thoughts? Are you excited that the demo gods did not defeat me? I personally am pretty jazzed about that.
Yeah, we're 2 for 2 tonight on demos. I'm pretty pleased.
If you are interested in like learning about like EBPF and what's happening with Cilium and all the other stuff, we actually have a newsletter now. And so if you're interested in signing up for that, that's here at the bottom. And the newsletter will include things like crazy articles that talk about different EBPF projects that are totally unrelated to Cilium, just other EBPF projects that are out there. In fact, I think this one, oh, that was the sign up form. What? I'm going to be contacting the owner of this form because I'm pretty sure this is a mistake. Anyway, but you can also follow the Cilium Twitter handle, and we will announce the new newsletter every 2 weeks when they get shipped.
You've got a question in the regular chat as well, Duffie.
Yeah. You mentioned you were going to revamp the CNI migration process early in the presentation. Is that something you happen to have a timeline on? Yeah, you're probably going to see a blog on the Cilium blog with relation to that, because I do want to kind of go through and document like a mechanism for handling a migration case into Cilium. It's coming up more and more often, as you might imagine. As a field CTO at Isovalent, I'm getting that question a lot. So I'd like to definitely like revamp that effort and make sure that that's like a pretty viable path for existing clusters.
Any other questions for Duffie, folks?
Wouldn't be surprised to see that show up on Echo office hours.
So the Cilium encryption layer is IPsec
Or
right now?
WireGuard.
Or WireGuard. You can do WireGuard now as
Mhm.
well. Cool.
Yeah. Any other questions you have about Cilium or any of that stuff? Otherwise, we probably go to social, I guess.
Yeah. With that, we will close things out and go to social. Thanks again, Duffie.
My
It was
pleasure.
really great content. Always enjoy having you here to share with our Atlanta community and beyond when it goes up on YouTube. As always, when we get to the end of the meetup here, do a call for speakers. If you've got a topic near and dear to your heart and you would like to present that to our community here, please reach out and let us know. Or if you have a topic that you want to hear somebody talk about, let us know and we'll go out and try to find somebody that's expert or near expert on that to bring in and share some knowledge with us. Please, yeah. We always like to have people from our local community represented, so please reach out. We love to have you. And that being said, I want to thank Salesloft again for sponsoring the Zoom and such as per usual. And if you hang around, we'll be converting folks over to panelists, so we'll all be able to talk after we stop the recording. Thanks, everybody.
Thanks for coming, everybody. Thanks, my buddy
Thank you.
Joe, and thanks to our speakers. We're glad to have you all here.